Thank you, Irene, for the introduction. And now I will be talking a little bit about how inheritance filters are designed and why scientific designs are important. So normally this is a question for you all. So how long do you take to analyze an exome case? It can range anywhere from few minutes to few hours. Of course, it largely depends on the reporting regulations of your laboratory, but also to a large extent on which software you're using for analysis and the flexibility it offers. Now, I'm very proud to say that several of our users are able to finish analyzing an exome case from 15 to 20 minutes, and you would always hear positive feedback, so feel free to talk to our users. And there are two ways you can do the analysis with varvis. Now, each one takes responsibility for their own cases, builds their own filters. So these, we say, are filter buttons that you are able to create for yourself, and then analyze the case. Or another way is that, based on the SOP, one person puts in the effort to create these filters, shares it with all the colleagues in the laboratory, and then you go ahead. Now, an important part, after you apply all the basic filters, you would have to then, when it comes to families, then you would have to look at segregation manually. And this is where inheritance filters come in, that you're able to apply these inheritance filters in addition to the basic filters so that you don't have to look at this segregation manually, and it's made easier. Now, as you can see, these are the filters that are available normally, and there are some special filters in varvis, and I will show you how these filters are designed. And this is important because it would show you which variant is included and excluded when it comes to segregation. Now, some of the common solutions that you would see utilize affection status, zygosity, mode of inheritance, segregation in duos, trios, but what is missing is segregation in large families, and sometimes you have mosaicism in the parents, which becomes a challenge. And then you have the pseudo-autosomal regions in the sex chromosomes that follow the autosomal inheritance pattern. And then there is CNV, a second hit when it comes to compound heterozygosity. So now I will start off explaining how regular de novo filter is built. So this is what you would normally expect, that you have an affected individual who's heterozygous, absent in the parents. But what if it comes to X-linked? Then you have to start differentiating the sex, male, female, hemizygous, heterozygous. Now, an added complexity is when you have the pseudo-autosomal regions. And then you have to start creating exceptions, saying, okay, if it is a pseudo-autosomal region, then just get back to the autosomal inheritance patterns. So this is just a very simple filter. But now let's see what it can be. So in varvis, there is a separate de novo filter, and we also consider PAR. When it comes to other filters, one thing that you can consider is mosaicism, like I said earlier, in the parents. You would see another affected siblings who is heterozygous, but parents are wild type. Now, do all filters work in such a way that this is incorporated when you click on this? That's the question. And then you have de novo homozygous variants, which have been reported. And do filters also filter these variants in where parents do not carry this variant at all? So it could be either this situation or this. And so varvis considers affection status, zygosity of all family members, and also considers de novo variants. When it comes to compound heterozygous filter, I would think this is the most common filter, complex filter, and you also have mosaicism adding a layer of complexity to this. So when it comes to this, it's possible that one of the parents are mosaic, and then you have affected individual who is compound heterozygous, but the parent does not carry it. But then there is a second hit CNB. So this is an added layer. And then you have the X-linked compound heterozygous, where then you have to differentiate between the sexes, and then also, in addition, the pseudo-autosomal region. So building these complex filters, and not all tools consider all aspects when it comes to analysis and filtering down variants. So we need to keep scientific aspects in mind when we are looking at inheritance filters. So we consider segregation and de novo variants in CHDN, and also consider CNB. Our user manual is quite it's quite open to our users and very transparent. So the users are able to go into the manual and see how these are designed. They see the workflow, the flow charts. So you understand why a certain variant is visible or not visible. And in summary, so choose your analysis tool with caution when you want features that you are able to apply during analysis, and accuracy of scientific designs are important. And we validate our pipeline extensively, and validation is an important aspect of a scientific tool. So in short, not all dishes that look the same taste the same.